Good afternoon, dear Chromium and Chromium OS developers. My name is Alexander, and I will be talking about Chromium on Chromium OS specifics. At the end, we will have questions and answers session, so please ask your questions to the service that you can see in the top right corner. Um, and yeah, and I will be happy to answer your questions. So Chromium OS, Chromium on Chromium OS is a little bit different from other operating systems. I won't be able to cover everything, so I will try to focus on a few specifics that many Chromium developers outside of the Chromium OS are missing. If you are developing Chromium shared code, or Chromium OS bundled applications, or built-in extensions, I will try to cover a few important things about Chromium OS that will help your code run smoothly. First of all, we need to remember one of the main Chromium OS principles: never prevent users from accessing their data. For example, the only UI users have is Chromium. If Chromium fails, users will never be able to work. If Chromium fails to sign in, users will never be able to work too. In simple words, do not break the device. A check in code can effectively break the device. We should also keep in mind that file system data can become corrupted and provide fallbacks. Working offline is also important. If the device cannot access Google or another service, we should try to give users the best available option. Chromium on Chromium OS is not just a browser. It also implements many important functions. First of all the UI is drawn by Chromium. In addition to that, Chromium implements many system functions as Mojo Router Service, Window Manager, Wayland Server, device settings, and many more. Basically, these are the functions of a regular operating system. I will not discuss most of them. My main goal is to highlight a few important things that Chromium developers should keep in mind in order not to break Chromium OS. What is Chromium OS from Chromium developers' point of view? We can imagine a simplest model of a Linux operating system that runs a single process called Chromium, which implements all user interactions. Of course, it's a little bit more complex in reality. Let's discuss the flow that is very different from Chromium behavior on the other operating systems. First of all, it's startup and initialization. Chromium is a web browser by nature. To display and navigate web content, it needs to be able to store cookies, history, cache, and so on. For this purpose, Chromium is using the profile object, which is always backed up by the user profile directory. To store consistent user preferences to disk, profile object is destroyed to prevent further changes after the last file sync. On the other operating systems, Chromium starts knowing the path to the user profile, which is backed up by the directory on the hard drive. So the user profile is usually a key object, and all Chromium paths depend on the profile. On the Chromium OS, user data is encrypted. We call the encrypted data user directory cryptohome. So before the user types their password, and we decrypt user data using this password, the user profile is inaccessible. But to get this user password, we need to show the login screen. And even more, the user may first need to connect to the Wi-Fi or another network, configure proxy or another device parameters, and we will load and display HTML for that. How does it work? Let's look at the system from the bird's eye view. Chromium OS device is powered on. Linux boots. Chromium starts. At this point, all user data is still encrypted. User profile is inaccessible. Then user types their password, which is used to decrypt their cryptohome, which also stores the user profile directory. Chromium loads the user profile and starts a full browser session restored in Windows, browsing history, cookies, and so on. Now a user decides to stop their session. They press the log off button. Chromium process is stopped, cryptohome is unmounted, and user data is inaccessible now. A new Chromium process is started displaying the login screen. This flow looks very simple until we dig into the details of what happens at each step. As we are talking about Chromium, let's see how Chromium starts a new user session. Chromium starts with a login UI. After the user types their password, we mount the cryptohome, present the user with a post-login UI, which is usually first-run UI, and then start the user session by creating a browser object. The important questions here are at which point Google user ID is known, so that we know which user has just logged in. When is the user profile created and possibly loaded from the disk? And when is the user profile first used to display content? This is where we know the Google user ID. This is important because it can potentially change from the previous session. And if your model is working through the login process, you should keep this in mind. This is where we create the user profile. Remember that at this stage, login UI is still displayed. And here we shut down the login UI and create a browser object. And from this moment, the user profile is used to display the content. Login UI used to be web-based, so that we loaded the actual HTML page to let users type their credentials. Even though currently the main login UI is not web-based, it can still load web elements, and post-login UI, which is usually the first run UI, is fully web-based. And even more, we have some bundled extensions which work on the login screen. Well, browser extensions require a valid profile. Displaying HTML also needs a profile. How does it work if user profiles are inaccessible at the login screen? For that, we use login profile, which is created when Chromium starts. This is also an ephemeral profile, which means that all the changes to this profile will be discarded after the UI that is using it was destroyed. This is important, for example, for the bundled extensions that are run on the login screen. At some point, they will be loaded from the new profile, and they need to correctly handle this. Let's bring back the picture of the login process. If you look closer, you will see that there is a moment when the user profile was already loaded, but the UI is still displayed using the login profile. So if you are developing an extension that goes into the user session, please keep in mind that we have several technical profiles that are used for specific purposes, or specific UI, for example. Bundled extensions must handle UI profile switching. There is no general rule of how to handle this transition, because it depends on the model logic and whether you want to keep the login behavior into the user session. Just keep in mind this transition. The common issue here is delivering events into the wrong profile, which leads to either data loss or crashes. Another important point here is that after the user profile is created, and before it is actually used, we may display a special UI that helps users to configure some session parameters. If you develop a new model, for example, a bundled application, you may start initialization after the profile was created. But user might change some key preferences before the session is started, and in this case, your application will be initialized with incorrect settings. Let's see how events can be mishandled. When a profile is created, extensions are automatically initialized. Bundled extensions receive the control and can start generating events. But UI belongs to a different profile. So if extension doesn't correctly handle this, your user actions may be lost. As I said, after the profile is created, it automatically initializes built-in applications. But at this stage, some of the preferences might not be finalized. For example, the UI language. After the user logs in, we may still present some UI that helps configure the user session. Also at this point, user UI language preference may not be synchronized. All the UI that is displayed before the user session start is capable of dynamic UI language switching, so it is okay to switch language at this stage. But here we see that some in-session only UI, like bundled applications, may be initialized before the session starts, and they may use wrong configuration and bring it into the user session. For example, if you need to download some language packs for your application that match the user UI language, you might download wrong data. So in most cases, the in-session UI should be initialized only after the session start. Otherwise, it might use wrong configuration. But before I talk a little bit more about profiles, let me step back and talk about Chromium OS users. Let's take a look at the login screen. Usually you can see user ports for existing users. If I focus one of them, some of the user preferences will be applied to the login screen. User wallpaper will be loaded, and user preferred keyboard layout will be activated too. In addition, we know the user avatars and display names. But by this time, user profiles are still encrypted and inaccessible. Where does this data come from? And the answer is that it's part of the Chromium OS user database. Let's look at the key differences between profile and user objects. User object represents Chromium OS user as an operating system user. Every user has a corresponding profile object that is available after signing. And you can translate them via getUserByProfile and getProfileByUser. But the lifetime of these objects is significantly different. User object is usually created when Chromium starts. We populate the list of users from the local state. It is never destroyed unless the user is deleted. It is guaranteed to be a single object per user in memory. Profile object is created only after the cryptohome was decrypted and mounted. It is destroyed before Chromium executable is stopped to store consistent user preferences database to disk. Another important profile feature is that it can have a clone if the user is logged in ephemeral mode, which means that if you are working on a model that will run before user session starts, you likely need to store data per user, not per profile. You can find profile objects by user object and user object by profile object. Of course, getProfileByUser can return null pointer if no profile was created yet, or profile was already destroyed. The fact that the user object is never destroyed is important, because it helps to run UI if the profile was already destroyed, but Chromium hasn't finished yet. There are a few important special Chrome OS users. The sign-in user with login profile is used to display the login screen. More precisely, it is used to display all the UI before the user session starts. The kiosk user. This is used for the enterprise kiosk sessions. The guest user is used for browser's guest sign-in mode. Please note that guest user is intentionally unconfigurable to provide users with a safe alternative if their primary user fails. Public session user. You can think of it as an enterprise-controlled guest user. Special users are usually ephemeral, which means that any changes to these profiles within the session are not saved and will go away after Chromium shuts down. So every session of a special user starts with a fresh data. Every ephemeral user actually has a real prototype profile that is cloned at the session start. Logout process is much simpler. After the user requests session end, browser object is destroyed, profile preferences are synchronized to disk, profile object is destroyed, and Chromium process ends. This will trigger cryptohome unmount and start of the new browser process. Let's sum up what we discussed about guest and ephemeral users in general. Ephemeral user is a Chromium OS user which will lose all the cryptohome, and this way the profile changed at the session end. Guest sessions are always ephemeral. Most of the special users are ephemeral, but don't really have to be. Any regular user can log in ephemeral mode. This is a special enterprise feature. Ephemeral users have two profiles, regular one and ephemeral one. And you can check whether the user is ephemeral via isUser non-cryptohome data ephemeral. I mentioned that we can switch UI language when entering user session. If you are developing Chromium for another operating system, you probably know that Chromium requires restart to change UI language. But this is very different on Chromium OS. All the UI that can be started before the browser start must support dynamic language switching. This is important when developing shared components. For example, networking configuration UI is used both in the Chromium settings page and on the login screen. This is a shared component and it must support dynamic language switching. Shared system UI, tray menu for example, must support language switching too. Bundled extensions also should support UI language switching. And if you are not developing shared code and do not want to explicitly support UI language switching, please consider initializing your model only after browser starts. And as a reminder, we have a list of questions that I will try to answer at the end, and the link to the questions is in your top right corner. A very important case is multiprofile mode. This mode allows several Chromium OS user profiles to be used to display system UI at the same time. We call the user that has started the session a primary user, and it has primary user profile. In this mode, each user can have their own set of extensions loaded, including input methods. The tricky part is event and preferences handling, especially for the user actions. Active user switch is a synchronous event. So between the user switch request and actual switch, there may come a few events that cannot be handled by the new user. Actually, this issue is not specific to the multi-profile mode. It is very common when there are several profiles loaded. The solution is to always remember which user or profile must handle this event. The important fact here is that this flow is not specific to real users. Basically, switching from the sign-in special user to the real user happens exactly in the same way. So this mode is an illustration of how several users, including special system users, can be loaded at the same time. So the issue above can be avoided if you never, or at least limit your use of getActiveUser and getActiveUser profile. In most cases, you already know from the context which profile should receive the event. So please always use the correct one. When we create a Chromium OS user, it usually happens via the Google sign-in. So it naturally has Google account credentials. But there is an important difference in the lifetime of the Google sign-in and Chromium OS sign-in. Chromium OS user is bound to the user session. There is always a valid primary user object associated with the user session. Google authentication is different because it matches the external authentication state. For example, Identity Manager getPrimaryAccountInfo may return null pointer if the user is not a Google user or is not authenticated, which may happen somewhere in the middle of the session. Remember that Chromium OS has non-Google users too. This includes local user types and non-Google accounts, like Microsoft Active Directory accounts, for example. My suggestion would be to use user getAccountID to identify Chromium OS users. It is consistent with the local data storage. And if you need account data to talk to Google, use Identity Manager instead. Sometimes you may want to store some per-user data outside of the user crypto home so that it could be used before the user session starts. And local state is usually the default storage for this data. But storing user data outside of the crypto home needs to conform to three main requirements. User ID may change. User may not be a Google user. And user data must be consistently deleted when the user is deleted. There is a solution that does it for you. It is called User Manager Known User Database. In addition to storing per user data, this database is also capable of translating incomplete user ID into system user account ID. You usually don't need to add your special storage to the local state or outside of the crypto home, because you will have to deal with these three requirements and maybe some future ones. If you really want to store user data outside of a known user database and outside of the user crypto home, there is a special identifier that was designed specifically for this. Still, storing user identifiers to any permanent storage is prone to future changes, but getAccountID key from the account ID object is the current best solution to this. Chromium OS users can have different local roles. Device owner preferences control device defaults. Primary users control session. Secondary users control only their part of the session, which means that some data is shared between user preferences, local state database, and device settings. To handle this, we have special structure which is called Chromium OS Preferences. It handles preferences like input methods, time and date, mouse and touch behavior. So basically it is the default handler for the Chromium OS Preferences. If you need a preference that controls device behavior, add it to the Chromium OS user preferences and implement its handling in Apply Preferences. When developing a bundled extension or some other UI that is not a direct part of the system UI but interacts with it, remember to talk to the team that owns the system UI. The issue is that system UI developers must be aware of the behavior of your extension to make it all consistent. As an example, session state is not suitable for synchronizing UI behavior because it was designed for the user invisible services and doesn't really match the UI state. UI changes should be usually driven by the system UI team. So it is better to talk to them first and not rely on the existing events that you may find. Well, that's the end of my talk. Let's check the questions. Well, as we don't have questions right now, thank you very much for watching and see you next time.